Hey, welcome back, everybody. This is part two in our final Geometry 24-25 review video. If you didn't watch the first video, please make sure you do that. It covers questions 1 through 3. I'm going to be jumping right into our next question. This video is going to be about 15 minutes. So put on your seatbelt, get yourself a drink, and get ready to write this stuff down. All right, let's crack on. And again, if you guys have questions, you know how you can contact me. I'd be glad to help in any way that I can. All right, first and foremost, number 4, it says, we are given the line y equals 2/7 x minus 4. Which lines are perpendicular? I'm going to start by identifying the slope here. This is in the form of y equals mx plus b. So I know my slope from slope-intercept form, which you guys know, is going to be 2/7. So the original slope, which I'm going to call the OG slope, is 2/7. Now, what we have to do is find the slopes perpendicular. Now, our perpendicular slopes, remember this is our symbol for perpendicular slope, is the opposite reciprocal. So that means I need to flip my fraction, 7/2, and make it opposite. So I'm going to make it negative. So I'm looking for -7/2. So I'm going to go through here. Notice we have y equals mx plus b, -7/2. This one works. We look at this slope here. Well, this one is 2/7. This one will not work, right? It's just opposite. We're going to slide over. I'm going to look at f, which is also in y equals mx plus b. Notice that's the same slope. Of course, that's not going to work. So we have 3 additional options here that we are going to be looking at. Next, we have letter B. Now, letter B is in point slope form, which is y minus y1 is equal to m times the quantity x minus x sub 1. So we can see here is our m. Here is our m. In this case, our slope is 7/2. Well, 7/2 is close, but it's not opposite. It's just the reciprocal. Not going to work. Letter D is also in point slope form. Here is my slope. Oh, look, -7/12. Or sorry, 7/2. Boom. We have our answers, A and D. We didn't even really need to use the graph here to do that. But I just wanted to show you guys, again, our slope is rise over run. And if we have to do that graphically, we can count those spaces. All right, in question 5, we are asked to describe the sequences of transformations to get these two shapes on top of one another. Now, there are a few different ways you can do this as well. What I'm going to do is, since this is a mirror image of itself, I'm actually going to use a reflection. I'm going to create a line, and I'm going to call this line DZ. And notice I'm marking that there. In fact, I'm going to make this a solid line. I'm creating a line DZ. Let's chunk in. There we go. DZ. And DZ create line DZ, which bisects that middle angle, and that middle angle is angle CDG. This is splitting this in 2 equal pieces. If I know that to be the case, that means it's directly in the middle of that. So once I have that line created, all I need to do is reflect my polynomial polygon, not polynomial, ABCD over the line DZ. And because this is an angle bisector, well, I know these two distances are the same. It's going to reflect those 2 points on top of one another. Thus, it's also going to be equidistant from here, B to F, and the same thing from A to E. So it's going to map them on top of one another. So we can just do that by really 2 steps. Easy enough. In question 5, we are asked to prove that segment BD is congruent to segment AC. BD and AC. And I'm going to pause. So we're going to be looking at this and trying to figure out a way that we can do this. So as I mentioned, we're trying to prove these 2 diagonals to be congruent. Now the nice thing is we are told that this is a rectangle. A, B, C, D is a rectangle. Since A, B, C, D is a rectangle, AC is a diagonal. It goes across, it cuts through and connects 2 non-adjacent vertices. BD is also a diagonal. You can see it goes across and connects 2 non-adjacent vertices. Since AC and BD are diagonals and ABCD is a rectangle, well, I can say AC is equal to BD because in rectangles, all diagonals are congruent. So instead of just going through and proving these triangles to be congruent, which we could use corresponding parts of congruent triangles, I think it's easier just to utilize the fact that this is a rectangle. Since they tell us this is a rectangle, we're going to use that property of rectangles. Make it as easy as possible on ourselves. All right, so next we are looking at question 7. So I'm going to zoom out to make sure I'm going through this in the right order. Looks like I may have went a little bit out of order here. I think we're fine. No, we're good. We're good. We're good. All right, so we just finished up with the calculator section, or the non-calculator section, questions 1 through 6. We're going to slide over to the part 2, which is the calculator section. All right, so the first question we're looking at, it says, how many small cubes make up a big cube? So we're looking at volume here. So it said that this cube is 3 grams. This whole cube is 3 grams. This whole cube is 378 grams. So if I want to figure out how many cubes are going to fit from one into the other, we use division. That's how division works, or what division tells us. It tells us if I take this big number, or the big volume, 378 grams, and divide it by our small cube, which is 3 grams, that is going to give us how many can fit, or how many of those can fit in there. Now, luckily, we can use our calculator here. So we go into our computation device. 378 divided by 3 yields us 126. So this would be 126 boxes. Same thing we're going to do for these cubes here. The smaller is 0.8 of a gram, and the other is 250. So I'm going to take the larger. I want to see how many 0.8 of a gram fit into 250 grams. So I take that. Again, I can use my calculator here. I know it's going to be more than 250. 250 divided by 0.8, 312 and a half. Boxes. All right. So now we're using a similar concept here. We're actually working with a real ingredient. It says olive oil is a cooking ingredient. The density of olive oil is 92 hundredths grams per cubic centimeter. An olive oil farmer wants to sell bottles of 460 grams. What is the volume of the smallest container that holds 460 grams? So from our studies, we know that density equals mass divided by volume. So we're told the density is 9,200, so I'm going to substitute that in. We're asked to find volume. I don't know what that is. I'm leaving that as V. And we are told that the mass is 460 grams. Grams is mass. So I need to solve this. Now, the way that I've always recommended that you guys solve this is by using cross multiplication. So I'm going to put this over 1. 460 times 1 is equal to 0.92 times V, or 9,200ths V. So that's going to give me 9,200ths V equals 460. We're going to divide by 9,200ths to get this V by itself. 460 divided by 9,200ths gives me 500. So this would be a volume of 500 cubic centimeters. Remember, volume we measure in cubic units. Back to another trig question. In question number 2 down here, it says find the volume, or find the measure of angle A. I'm going to circle angle A here. Now I'm going to label my sides just like I did in the previous trig question. Opposite, it's across from the angle. Across from the 90-degree angle is always the hypotenuse, and then the last side is the adjacent. Notice they gave us all 3 sides. We really only need to pick 2 of them. I mean, in fact, normally they only give us 2. So I'm going to just pick randomly, it doesn't matter. I'm going to pick O and H, because those are the easiest for me to find, really. I like that. So notice we're trying to find an angle. We're given O and H. So I need to figure out which ratio uses O and H. Well, cosine is adjacent over hypotenuse. That isn't going to work. Tangent is opposite over adjacent. That's not going to work. Oh, sine, OH. Sine is the only one that uses O and H, so I'm going to use that one. Sine of blank equals blank, and I'm going to fill in my angle, which is angle A I'm trying to solve for. My opposite side is 8. My hypotenuse is H, or 17, O and H. Now, in order to find A, we need to get that A by itself. So I need to get rid of sine. And the way we get rid of sine is by using sine inverse. So I take sine inverse of both sides. Sine inverse of sine of A equals sine inverse of 8 over 17. These sines cancel out because they're inverses, and I now know A is equal to sine inverse of 8 over 17. This I can put into a calculator. I am going to pull up a Desmos calculator on another tab and then do those calculations. So here's our Desmos scientific calculator. Make sure we're in degree mode. I know we've been using radians recently, but for this problem, we're going to be using degrees. So I select degrees. Now, I see sine, cosine, and tangent, but I don't want sine, cosine, and tangent. I want sine inverse. So I need to go to function, and notice here, sine inverse. And we are typing in, if I look, sine inverse of 8 over 17. Sine inverse of 8 divided by 17. Notice this gives me 28 degrees. I'm just going to round to the nearest whole number, which is 28. So this equals 28 degrees because this is an angle. All right, so that takes care of number 2. And it looks like we are approaching the end of our second video. I'll see you guys in part 3, where we're going to be digging into the last couple problems from the calculator portion. I'll see you guys there.